Okay, right now we want to solve this Leetcode problem. Okay, so I mean, um, one thing for sure is like they term it lah. They term it calling it a stack. So I mean, like fundamentally, a stack it just involve like this lah. Okay, so um, they call it a stack, but fundamentally it's just a list. So what we are trying to do over here, right, is that we want to actually find out basically the string, right, basically the thing, right, is gonna close properly or not. So if it's closed properly, we give it a valid. If not, we give it a thumbs down. So here's the thing that how do we actually do it, right? So the very first criteria that we actually set ourselves into is to say that there's the concept of like LIHO, you know, last in first out, you know. And that's what basically the stack actually does, you know. This one last in, right, but this got kind of first out. So with that in mind, we tackle the problem itself. So the very much first thing that we actually gonna do is that we're gonna come into the problem, okay, saying that okay, let's establish a stack itself. So we basically give ourselves a stack and then give it a empty stack itself. Establish a stack, good to go. And then the next thing is we create a dig. Okay, we create a dig that actually comprises of, it's not an empty dig, it's much more of like giving ourselves that, saying that okay, if you key in this key, right, then I'll give you back a value itself. So it's like connecting the close with the open. So if you give me this, if you give me a close, I will say that you are actually trying to tell me this. Okay, so as with that in mind, we go into the problem itself. Okay, so if that thing it doesn't fit the criteria, right, we give a else statement of giving a return, you know, a return for of saying that we're gonna plus into our stack itself. So we're gonna like give the else statement of plusing. We do a append of the C product itself into our stack. So you're gonna like okay, so like, and what is like the condition for ourselves? So we need to set the if statement. The if statement stating that if so we do a C in S, a for loop itself, a for loop for the C to come into the S to go through all the variable itself, and then if that thing, right, C not in stack, If C not in stack, if C in stack plus N is like connected to our dig, and which part of the dig that we want to actually talk about? The variable C. Because fundamentally, if we were to talk about dig, right, is that how it actually work is that you need a key value, we need a key and the value itself, and then the dig. So if you're saying that dig variable, right, dig and a key, dig and a key, so this thing is the key and this one is the value itself. So if this thing coincide with very much the last stack itself, because the thing that come in, right, we are trying to find a close bracket, which is this. And then if the very much the last stack itself, right, is this whole thing, right? What we want to find is the close one. Then the last scope one, right, must be this. And then if this thing and then the stack, right, the stack minus 1, right, the very last variable of that thing, right, is this open run, right? Basically, what we are trying to establish over here, right, is this. So if this criteria pass through, right, first thing is like it go through this value, saying that there's an open and a close, and then by going through this, that's the first condition. Then the second condition, right, is that if, right, C is like, what does that actually mean, If it's not in the list, then we add it in. If it's not in the list, then we add them in lah. Yeah, if it's not in the stack, that's one of the other condition that it must be. If not in the stack, plus this second condition, right, then it can pass through. If not, right, we add them in. So then we start to actually collate. Doing, doing, doing until like we find until like the close background, then go through this thing, go through this thing, go through this thing. Basically, it's not in stack. Then we come into the conclusion of like saying that what kind of conclusion do we want to have? Oh, we do a pop. We delete the thing. We pop like the last variable itself, so just like that. Then it's called a stack. So a stack, right, will remove. So this will cannot cancel out. Then each time it come in, right, it cancel out. And then it cancel out. But if it's the wrong one, right, that's why we do another else statement saying that return false, because we want a boolean to be false, right? Then if it doesn't fit in all of this condition, right, then we say that if basically not in stack, right, that means we're giving an empty stack, then we return a value of true, else we return a false. And there you have it. That's the end of the elapsed period of like delivering a point of like saying that how to actually utilize. I think the main thing about this, right, is we actually abuse the date. While this thing all crazy, then others just fall in place. And then we abuse of like the list itself. We abuse the factor of like the last in first out property, then we can actually pop the value itself. We are abusing like these two properties for ourselves to actually solve this Leetcode. So yeah, that's the elapsed period.